sine theta is equals to y over r, where r is the radius, and we also have cosine theta is equals to x over r. Radius is denoted by r. Okay? Then we extended that formula, and we realized that for obtuse angles on page 38, flip to page 38 now, we realized that when theta is obtuse, that means more than 90 degrees, sine theta is positive and cosine theta is negative. Okay? And we saw the relationship between sine 180 degrees minus theta. It is the same as sine theta. We also saw that cosine 180 degrees minus theta is the same as negative cosine theta. So we also went on to example 3. We saw that when sine theta is equals to 0.5, we had two answers equals to 0.5. We saw that theta could actually be equals to 30 degrees or 150 degrees. One of them is acute, the other is obtuse. How did we get two answers? We used this over here, this relationship, sine 180 degrees minus theta equals to sine theta. We used this relationship. In the past, when I told you that sine theta equals to 0.5, you would have just done this. Theta equals to sine inverse 0.5. Use your calculator, you press, then you get 30 degrees, and then you stop here. That's what you do in the past. But now, because we know this relationship, we know that there could be two angles. That gives you answer 0.5. How do we find the other answer? Right now, one of them is 30. How did we get this 150 degrees? We got it from here. 180 degrees minus 30, you get 150. Okay? So that was for example 3a. So let us move on to example 3b. Now we have cosine theta equals to negative 0.763. Okay? So we want to find theta again. How many answers do you think you will get? How many answers do you think you will get for theta? One answer or two answers? How do we decide? Okay, so we need to recall that on page 38, we say that when theta is an obtuse angle, cosine theta is negative. Okay, this is on page 38. This is what we have. Page 38. When theta is obtuse, cosine theta is negative. Okay, that is written over there. And we also learned at the start of this chapter 6, when theta is acute, cosine theta is positive. Okay, you can refer to the table yesterday that we filled out many numbers. When theta was between 0 to 90 degrees, all of its values, all of the answers were positive. Okay, only when theta was greater than 90 degrees, then we had answers that were negative. So based on this information, how many answers do you think you will get for theta? What is this sign over here? Positive or negative? Negative, right? So which case are we talking about? This one or this one? Top or bottom? Obtuse, yes. We are talking about this case. When theta is obtuse, the answer will be negative. Isn't it over here, negative? So we know that theta has to be greater than 90 degrees. Okay so far? So now, we can use our calculator, find out straight away how much is theta. So press with me. Inverse cosine. How much is it? Negative 0.763. What did you get? What do you get for answer? 139.7 blah blah blah. So 139.729 degrees. Only one answer between 0 and 180 degrees. Okay? So we round this off to how many SF or how many dP? We need more? How many dP or SF? 1 dP because it is in degrees. Okay, so this is 139.7 degrees. Is this an obtuse angle? Charmaine, is this an obtuse angle? Yes, it is. It is greater than 90 degrees. And it is correct. It is the same as what you mentioned earlier. So, if you don't believe, you can just use your calculator now. Press cosine 139.7. What do you get? You get negative 0.76 blah blah blah. Okay? So it's a negative answer. Alright? Okay, let's move on to the try it tree. Meaning try it yourself. Okay, I'll let you try part A first. Sine theta equals to 0.7. And note that theta is between 0 and 180 degrees. Use the steps that you see in the work example, just slightly above it, and work out the answers. Everybody should be looking at your book, doing your work now. Try it 3, part A. Okay, look up. Look out on the screen. Did everybody have this first step in red? Look up on the screen. Did you have this first step? Yes, okay, good. You can continue. Those who don't, write this down. Okay, you're done with part A. Let me continue with the solutions for part A. So sine alpha is equals to 0.7, therefore alpha equals to sine inverse 0.7. Okay, I do not want to round off yet. So since sine 180 degrees minus alpha equals to sine alpha, when sine theta equals to 0.7, theta will be equals to 44.427 or okay, did you all get this too? 44.4 or 135.6? Ali, do you get it? Anissa, you get it? Check your presentation, is it the same? Or largely similar? Because this is almost word for word from the work solution. This is what we expect to see. Natasha, do you get it? Okay. Anybody, any problems? Yes, Romualdo? Sorry? Okay. Okay, well, Ms. Mazura has explained to her. The rest, any questions on the process? If don't have, let's go on to part B. Part B, cosine theta equals to negative 0.625. So find theta. Okay, this one less than 1 minute, you should get it already. Alright, anybody has any problems with this? Part B? Okay, then I have a question. You know, in your exercise, your topic 6.1 to 6.4, your worksheet that I gave you, I had some steps given to you, like step 1 do this, step 2 do that, so on and so forth. Are those useful to you? Okay, then I shall give you some steps for this also. So copy this down. You notice that sine and cosine, sometimes the method of solving is quite different. So what is it that is different? When sine theta is positive, there are two values for theta. What are the two? Acute and obtuse. This obtuse value is just 180 degrees minus the acute value. Okay? So this is a summary of what we have done in try 3A. When sine theta is positive, there are two values. One of them is acute. You know how to get this acute because it is just sine inverse whatever number. And then you get the acute value. The other value is just 180 minus the acute value. That's it. Okay, this is the first one that you need to know. Second thing you need to know, when cosine theta is positive, there is only, okay, I shouldn't say only, there is one value for theta. It is acute. Okay, this is our basic one. When cosine theta is positive, there is only one value for theta, it is acute. You just express cosine inverse, the value, and you get the answer for theta. Next one, when cosine theta is negative, there is one value for theta. It is obtuse. Okay, these are the three cases that you need to know. It's not 3 steps, but these are the 3 cases you need to know. Okay, so not in syllabus will be when sine theta is negative. Not in syllabus. Okay? So don't need to know. Okay? Please take note of these 3 cases that you need to be familiar with. Once you are done copying this, I will tell you a little bit more about this angle theta. Who is not done copying? Raise your hand. Okay, copy fast. Who is not done copying? Faster, faster. Okay, so now I need you to copy this down as well. See your 1, 2, 3. There is a condition. The condition is theta is between 0 to 180 degrees. This is the condition. Okay? Because things get slightly more complex when you go outside of this range. If you're interested, you can ask me, I can tell you more. Okay? Okay, so let us try more examples. Turn with me to your textbook, page 42. Okay, exercise 7.1, question 2A. Have I told you the homework for this? Haven't yet? Okay, never mind. Just follow with me, take out a piece of foolscap paper because we are going to be attempting some homework questions right now. Okay, take out a piece of foolscap paper. Let us try question 2A. Sine 126 degrees. Now practice over here. What we are trying to practice is to rewrite these obtuse angles in terms of acute angle and 180 degrees, which shouldn't be too difficult. Okay? So this is equals to sine minus what? Okay, this one up. Primary school students also know how to do. Okay? What is the answer? What is missing? How much? How much? Minus 126. How much, Pina? 54 degrees. Okay? Understand what I'm doing? Expressing these in terms of trigonometric ratio of acute angles without finding the values. So far, okay? Okay so far? But there is still one more step. This is equals to sine what? 54. Okay? When you do more and more, then maybe you can skip this step next time. But for now, let us skip this step so that we know what is happening. Okay? Let us try another sine question. 2c. Sine 142 degrees. Okay? Equals to sine what? So fill in the blanks. So what did you have? Minus 38 degrees, is it? Okay, so what's the answer? Okay. Let us try one last one. Part E. Sine 158 degrees. You know, do you get it? Do you get answers? So for the last one, I just removed that step. I just put sine 22. Okay? So this is 2A, C, and E. Now I would like you to try by yourself 2B. Please take note, it is slightly different from your sine. What is the difference? 2B. Cosine 154 degrees. Equals to cosine what? First step. 180 degrees minus 26 degrees. Then this is equals to? Okay. So you didn't forget the negative sign, huh? I'll put it down in red for you to see. Negative cosine 26 degrees. See the difference between this and sine? For sine, when it is positive, it stays positive. Whereas for cosine, there is a switch. And why is there this negative sign over here? Okay, try the next one, 2D. Yankun, have you finished? Shafiq, have you finished? Finish or not? Afiq, okay? Have you finished? Okay, hurry up, hurry up. Shamin, finished? Then go on to part F. Okay, Zafira, what do you get for cosine 160 degrees? Before that, what is the step in between? 80 degrees minus 20 degrees. And then your answer will be? Okay, negative cosine 20 degrees. So this is what Zafira got and it is correct. And finally for 2F, cosine 99 degrees equals to? How much? 81. Okay? Okay, how do we prove that we are correct? How can we prove that we are correct? You are sitting in pairs, right? Let's try for 2F. One of you, use your calculator, press. What is cosine 99? The other person go and press. What is negative cosine 81? See whether your answer is same or not. Same, huh? Okay, so you are correct. Okay? Yes? We didn't do inverse cosine. We didn't do inverse cosine because they didn't ask you to find angle. Inverse cosine is to find angle. In this case, they gave you the angle already. Okay? So next, question 3. 3a. Find the value for cosine 98 degrees. Okay, what should we do for this? Okay, Ali says it is negative cosine, how much? 82. Okay, but now they want to get the value. They want the value, okay? So Ali, if you do negative cosine 82, what do you get? How much? 17, like that. Okay, somebody else go and try with your calculator, cosine 98, what do you get? Same lah. Has to be the same. Okay, so they want it in 4SF. So this is approximately negative 0.1392. Okay, I'm just showing you that both ways of doing it, you get the same answer. So it is your choice right now whether you want to just use your calculator, you press cosine 98, you get the answer, or you want to use your calculator, you press negative cosine 82, and you get the answer. Your choice. Okay, so question 3, your homework question will be, just copy this now, just circle them, 3, B, C, and D. We have already done 3A. Okay? But now, still got question 4. Okay, question 4A. Now in question 4A, we need to find the possible values for theta for which it is between 0 and 180 degrees. Remember earlier on, I said that, see, theta between 0 and 180 degrees. How many cases are there for our syllabus? 3 cases. They will fall within one of these, okay? So let's look at part 4A. Sine theta equals to 0.4. Does it belong to case 1, 2, or 3? Look at your question 4A. Sine theta equals to 0.4. Does it belong to case number 1, number 2, or number 3? Case number 1, because sine theta is positive. So how many values of theta are there? There are 2. What are they? Acute and obtuse. The obtuse answer is just 180 degrees minus whatever value you got before that. Okay? So let us move on to 4A. Let's see how we do this. And you have already done it in, I think, try it 3A. Okay, so sine theta equals to 0.4. What was the first thing that we did? Let sine alpha be equals to 0.4. That was the first thing we did, right? Then what did we do? Therefore, alpha equals to inverse sine 0.4. You get 23.578 degrees. 3 decimal places first. Don't round off yet. Okay? Gabriel, Francis. Okay. So now we have alpha is equals to 23.578 when sine theta equals to 0.4. Theta will be equals to 23.578 degrees, or that's another answer, right? What do you say the other answer was, Rabiatul? 180 degrees minus this. Okay, so this rounded off to one decimal place because we are dealing with degrees. So you get 23.6 degrees or 156.421 degrees, rounded off to be 156.4 degrees. Okay, this is 4A. So you are going to try 4B yourself at home for your homework. I will now move on to the next case, which is 4C. Cosine theta equals to 0.2222. So what is the value for theta? This one, case number 1. For 4C, case number 2, because the answer is positive, 0.2222. How many values for theta? One value. It is, what type of angle? Acute angle. We are expecting below 90 degrees. So this is easy. Theta is just cosine inverse 0.2222. And you get 77.161 degrees, rounded off to 77.2 degrees. Okay, then we have one last case to cover, which is 4G. Cosine theta equals to negative 0.061. Which case is this? Case number 3. For 4G, the value is negative 0.061. So negative. Third case, there is only one value, it is obtuse. And this is also easy to solve because theta is simply cosine inverse negative 0.061, and we get 93.497 degrees, approximately 93.5 degrees. Okay, so your homework for this question is 4BFH. Alright? Any questions? Okay, then let us go on to question 6 on page 43. Read the question, try to understand it. Okay, please try yourself 6A. Sine AC B. What is sine? What is the ratio for sine? Opposite of hypotenuse. Where's the opposite side? Huh? AB. Do we have the value? Then how? Can we get the value? How? Huh? AB is opposite, yeah, but how do we find the value for AB? How do we find the value for AB? Yeah, we can use Pythagoras. It is a right angle triangle. Then we can find AB already. And we have our hypotenuse. So you can find sine ACB. Okay? So by Pythagoras theorem, AB square plus BC square equals to AC square. So AB square equals to AC square, which is 13 square minus 5 square. And AB will be equals to square root of 144. CM. Do you notice that when I take square root over here, I didn't put in the plus minus? Then remember last time I keep saying that you must put the plus minus? Remember? So how come this time don't need? Yes, because length cannot be negative. That is why I don't have plus minus. Otherwise, if you are just doing algebra, you need to put in the plus minus. Okay? So AB is 12. Therefore, sine angle ACB is your opposite, which is AB over AC. And that will be 12 over 13. Any units or not? Are there any units here for sine angle ACB? What do you think are the units? CM. But this is a ratio, right? These are trigonometric ratio. Ratio got unit or not? No. Ratio no units. For example, we write 12 is to 13. Do we write in units? No, we don't. So, your sine, cosine, tangent, there are no units. Okay? So don't go and write units. No units here. Just for information, AB is in cm, AC is also in cm. Cm divided by cm, nothing left. Okay, it's just a ratio. Alright, so let us go on to part B. One cosine ACD. Okay, this is the angle we want. What type of angle is this? Obtuse. Can we find a right angle triangle with this obtuse angle? Cannot be lah, because right angle triangles, they don't have obtuse angles. So how are we going to find the trigonometric ratio of cosine ACD? Because cosine is adjacent over hypotenuse, right? Where is the adjacent? Where is the hypotenuse? For this angle ACD, can you find the adjacent side for angle ACD? Can you find it? You can't. There is no such thing. Because you don't have a right angle triangle with an obtuse angle. Okay? And then there is also no hypotenuse because there's no right angle triangle for angle ACD. How are we going to do this? So remember our relationship between obtuse and acute angles. This is obtuse, right? So how much is this? How much is this angle over here? Isn't this 180 degrees minus angle ACD? Right? This is 180 minus angle ACD, right? So cosine ACD is equals to, can I say that it is equals to cosine 180 degrees minus angle ACD? Can I say this? You sure? Do you want me to sound anything? Cosine, you know? Negative. There is a negative sign. This is the relationship. Natasha can follow? Okay, this is the formula that we have been using over and over again. Now we are just applying it from a diagram. Okay, so now we are ready to continue. Equals to negative. What is cosine of this angle over here? Huh? How much, Alfian? 5 over 13. Yes. Adjacent over hypotenuse. 5 over 13. That's it. This is our key step. Very important. Okay, tangent BAC over here. This one you should be able to do it lah. Shermaine, do you get the answer already? You get the answer? Do it. Tangent BAC. Irfan? How? Can follow? Cannot follow. Then never say? Huh? You can catch up by yourself. If you need help, come and find me, or Miss Maizura. Okay, so Sophia, what do you get for tangent BAC? What do you get for tangent BAC? Opposite over? So where is opposite, where is adjacent? Okay, equals to 5 over 12. Okay, correct. Let us try just one more question. 7. Okay, read the question, try to understand the diagram. Francis, have you finished question 7? Then why is your head on the table? We are trying to find the length. So how do we use trigo to find length? Charmaine, are you thinking? Darren, who's supposed to be beside you? Okay, where's Mars? Okay. Okay, any idea how to find WZ? Find WY first. Okay, so if you do that using Pythagoras, then what are you going to do with WY? Okay, anybody else? Any other suggestions? Find what? YZ. How to find YZ? Huh? How you find XZ? Okay, you can use tangent to find xz, then what are you going to do? Then you Pythagoras, is it? Then you minus 10 to get yz. But that's not what we want, we want wz. Okay, what Francis suggested can work. Okay, he wanted to use tangent to find xz, then use Pythagoras to find wz. But is there an easier way? What is it? Huh? Sine? Yeah, sine 30. I highlighted the triangle for you already. What do you have if you write sine 30? Wx over Wz. And Wx is given to be 10, right? Don't need Pythagoras already. Okay? It's not got units, no? cm. So this is 20 cm. Francis, if you try your method, you will still get the same answer. Okay, so let us go on to part B. Length of wy. Oh, wy, Sophia already gave us the answer. Wy square is equals to wx square plus xy square. 10 square plus 10 square equals to 200. So wy equals to square root of 200. Five SF, round it off to 14.1 cm. Okay, now in part C. Find sine of wz. So sine is equal to opposite over hypotenuse. Now, is there an opposite side to this red color angle? Is there an opposite side to it? All your opposite, adjacent, and hypotenuse, they are applicable only for right angle triangles. So is there a side that is opposite to this red angle, Anisha? Which side is opposite? Don't have. Is there a hypotenuse for this red color angle? Don't have, because don't have right angle triangle. So now you're stuck again. Cannot use your ratio. Then how? This is your WYZ. Huh? It is obtuse. Can we find a way to change it to a cube? We've done some exercises, right? This angle over here. What is this angle? Okay, yes, it is 45 degrees, but before that, what is the relationship between, let me use another color. Oops. What is the relationship between the red angle and the blue angle? 180. The blue angle is actually 180 degrees minus angle WYZ. Correct? So now, can I write down an equation over here? What is this equals to? No, not 180. It is equal to sine 180 degrees minus angle WYZ. Correct? This is the relationship that we've always been talking about. Once you get this, then what Wei Hao said is now very useful. How much is this? Okay, what he said was correct, but we don't really need it, okay? Yeah, because we can just take sine of this blue angle is opposite which is 10 over your hypotenuse, which is 14.142. I use small SF for my calculation. So this will be 10 divided by 14.142, 0.70711. Round it off, 0.707 cm. Okay? So, how can we use what we have said to check our answers? Now, based on our calculation, it is 0.707 cm. Based on the ratio that we see. So, Wei Hao said that it was 45 degrees because he recognized it is an isosceles triangle. Base angles are the same. So, take our calculator, you press sine 45. And what do you get? Sine 45. Hey, wait, this one no units. I said sine has no units, right? Yeah. So sine 45, you get 0.707. Okay, so your next homework is question number 8. So far this homework should be quite manageable. It is due on 12th July. Wait, your next lesson is 11, right? No. Monday, no lesson. Tuesday, you have lesson. Tuesday is 7, 8, 9, 11. Okay, sorry, it should be 11 July. Okay? Yeah. I gave yours. You all submitted your 6.1 already. Submitted your 6.2 today, right? Yesterday. Then today is 6.3. Then Tuesday is 6.4 and this one lor. Okay? Okay, now let us talk about chapter 7.2. It is on the area of a triangle. How many of you not confident for area of triangle? Half times base times height. It is very easy to say that the area is half times base times the height when I give you a right angle triangle. Right? Area equals to half times base times height. So what if the triangle looks like this? Then where is the base? Here. You want this to be the base. Okay, this can be the base. Then where's the height? This one, is it? Okay, this is the height. A triangle has 3 sides, right? Can this be the okay, let me label it A, B, and C. No, let's call it something else. X, Y, Z. X, Y, Z. You chose X, Z as the base because of the way I drew it. Okay, and then this is the red color over here is the corresponding height. But what if I choose Y, Z to be the base? Then where's the height? Let's say that this is also 90 degrees lah. Okay, make things easier for you. Then where's the height? Yeah, XY will be the height. If this is 90 degrees. Okay? And then there is one last case. Let's say this over here is the base. If XY is the base, then where is the height? YZ is the height lah. Okay? So for one triangle, any side can be the base. The issue is trying to find the corresponding height. Okay? So area is still half times base times height lah. And now for the last type of triangle, if it looks like this, and then I have x, y, and z again. If x, z is the base, where is the height? The height must always be perpendicular to the base. Okay? So if this is my base, where is my height? Is this the height? No, right? Because it's not perpendicular to the base. So where is the height? We can extend our base with a dotted line. Then this will be the height. Right? It is perpendicular to the base. You need to be familiar with all this, huh? Any questions on this case? Okay. So now, if YZ is the base, then where's the height? If YZ is the base, where's the height? This way? Yeah. Okay. The height must be perpendicular to the base. So, in green color. Okay, then, now comes the last one. I said that XZ can be the base, YZ can be the base, right? What about YX? Can it be the base? Of course it can. Then, where's the height? Okay, so use another color. What color should I use? If this is the base, then where's the height? I need to dot this down. Dot, 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 dot. Then, this over here will be the height. Height perpendicular to base. Okay? All triangles can have 3 different bases with 3 different corresponding heights. The formula half times base times height is applicable for all of them. Okay? So let's recap for area, which is half times base times height. So right now, let us take a look at activity number 2, which is on page 45 of your textbook. We want to find the formula for the area of a triangle. You already know half times base times height. There are actually more formulas for the area of a triangle. So let us complete the boxes with the appropriate expressions. Okay, right now we have a triangle in the diagram, ABC. And the side BC, 13 units. The side CA, 15 units. Angle BCA is 50 degrees. And they drop down a vertical line from B to the line CA. So that is why it is perpendicular. And that H over there will be the height. Okay, perpendicular height. If you choose CA as the base. So, we can write down sine 50 degrees is opposite over hypotenuse. Okay, so sine 50 equals to your opposite, which is H over 13. Therefore, H must be equals to 13 sine 50. Okay, so fill in the blanks. H equals to 13 sine 50. So since we also have area of triangle, look, I drew this triangle over here, but we are not allowed to do this anymore. We need to spell it out. ABC is equal to half times base. Which one is the base? AC, okay. Half times AC times the height. So this is half times 15 times, what is the height? 13 sine 50 degrees. Right? Half times base times height. Okay, so far? Okay, so I'm going to draw the triangle out. This is what we have. B, C, A. this is 15, this is 13, and this is 50 degrees. What we have just concluded over here, that I'm highlighting, I can apply it to a triangle if I'm given this information. Side, side, and the angle in between. Okay? So if I'm given a triangle with one side, and angle in between, I can tell you that the area of this triangle is half one side times the other side times sine 50 degrees. Okay? One more time, I'll just say one last time, then we'll end. The area of a triangle, this ABC over here, area is given by half times one side times another side times the angle in between. So now you know two formula for area of triangle. Half times base times side, as well as half times side times angle in between. Okay? Yes, as some of your seniors may call it half AB sine C. That's one way to remember it easily. Okay, half AB sine C. But I choose not to use that because it can be quite confusing if I have C here, B here, A here. Very confusing. So half times side times the angle in between. Okay? Class 10. Thank you, class.